Okay, hey girls. Welcome to Digital Learning Day #1. So hope you guys are staying well and having a little bit of fun over these strange days off. And maybe you're ready to actually get back to some schoolwork for a while. So anyway, I wanted to go over briefly the schedule before spring break. I know E-Block, I kind of talked to you guys on Friday about it, but B-Block I haven't. But I'll briefly go over what it's going to look like. So again, B-Block, so today's Wednesday, so you should be listening to this video. This will be the last new material for Chapter 6 before spring break. E-Block, you guys are doing the same thing on Thursday. Again, this video, last new material. B-Block, Friday, you'll have a review assignment. That's another digital learning day, so it will just be a review assignment posted on OneNote. E-Block, you guys will get that on Monday. This will not be an optional review assignment. It will be required, again, because it's a digital learning day. You will get points for it, completion points, but I will check it, make sure you completed it. So Tuesday will be the first virtual review day in E-Block. That will be a virtual review where we'll log into Microsoft Teams and we will go over the review assignment, answer questions, etc. Unfortunately, for E-Block, and I told you guys this on Friday, we don't have that extra day, but I will be posting a couple different options to have an optional review day on Tuesday after school hours. So that'll give you guys, it won't be required if you don't feel the need to check in. You don't have to, but on Tuesday after school hours, I'll set aside about a half hour, maybe 2 times, to see if anybody wants to check in and ask you some questions, okay? Because we won't have much time to go over any questions on test day. So you will both be having a test. B-Block, it will be Thursday. E-Block, it will be Wednesday, and we will log on to Microsoft Teams. We will take attendance. We'll make sure everybody's there. Then I will have you guys actually probably won't be using OneNote, but it will be, as of now, it will be a multiple choice test on Pearson. That I will be on class policy, checking you guys or watching you guys' screens as you're doing it, monitoring where you are on class while you're taking the test, and using Microsoft Teams to control the time that it's available. So again, there's still a little bit of a question mark as to how all that's going to work, but just know that you will both be taking an equivalent test. They won't be the exact same test, but they will be equivalent tests, taking them online during our class time. And I will adjust the number of questions for the 45-minute time frame. So don't worry about that. So anyway, if you have any questions or concerns about that schedule, you can email me or we can talk about it. Or actually just email me if you have it. B-Block will be able to take some questions on the virtual days and E-Block on those extra virtuals. But if you have any real concerns, let me know. Okay, so hopefully you've checked your homework. Answers are posted in OneNote. If you have any questions about the homework, again, shoot me an email, especially if it concerns last night's homework, or the homework that you checked today as part of this assignment, as part of this digital learning day. Let me know if you have questions. Okay. So last chapter, or last section, 6.5, solving square root and radical equations. So, and actually this should actually say square root and radical and rational exponent equations, okay? So just like all the other chapters, we usually end on actually solving equations. And what that means is now we get the equal sign, right? And the equal sign helps us, a lot of different steps are involved with getting that equal sign, so you'll want to go over those, and they're going to be listed right here. But the good thing about an equal sign is we end up getting x equals some number, so which makes our life a little bit easier. And similar to like absolute value equations and rational expressions, with this section, we also have the possibility of extraneous solutions. So, and again, extraneous solutions mean solutions that are not really solutions. So you have to check your answer. So again, we'll get to that as we go through some examples, but just kind of keep that in mind. that we will need to check our answers. And on this one, there's a real possibility of extraneous solutions, so you definitely make sure you do that. But again, we'll talk about it. So for all the equations we're going to talk about today, whether they have a radical, a square root, or rational exponent, the steps are pretty much the same. We're going to first isolate the radical. So that means getting the radical by itself, right? The radical or the rational exponent, etc. Whatever the focus is, we want to get it by itself first, isolate it. Then we want to undo the radical or the rational exponent. And by undoing, that might mean that we square it, okay, if it's a radical, or some other method, which again, we'll talk about it. Next, for all of these, then we want to solve for x. We'll have a simpler equation to do that. And then we'll want to check our answer using the original equation, okay? So all the problems we're going to look at now follow the same pattern with a little bit of different or little tweaks along the way, depending on whether we've got a radical or a rational exponent and a couple other things. So, but that's our main steps. So let's take a look at this first one. So solving a square root equation. Again, we want to get the square root or the radical by itself first. So we're going to subtract 3 from both sides. And we get radical 2x minus 3 equals 5. So now we want to undo that radical. And again, when you think about it, when we were trying to rationalize denominators, right, and then we wanted to undo that radical, get rid of that radical 2 on the bottom, we multiplied it times itself, right, or we kind of squared radical 2. So that same method happens here. To undo that square root, we're going to square both sides. So if we square radical 2x minus 3, we get just regular 2x minus 3 equals 25. And now we can solve. So we have a simpler equation. So we can solve, add 3 to both sides. We get 2x equals 28. Divide by 2, we get x equals 14. Okay? Again, we want to be careful of extraneous solutions. So we're going to check that by plugging into the original equation. So we go to our original equation. We plug in 14 and solve. So we get 3 plus 28 minus 3 is 25. Radical 25 is 5. 3 plus 5 is 8. So we're good. We got a good answer. Okay, so again, on a square root, isolate the radical. In this case, is a square root. Undo the radical, in this case by squaring it. Solve for x and check your answer. Okay, so let's try another one. So again, if we look at this one, we first get the radical by itself. So we're going to add 5 to both sides. Get radical 4x plus 1 equals 5. We want to undo that square root. So we square. We get 4x plus 1 equals 25. Now we solve. And we get x equals 6. Again, we want to check that. We plug it into our original equation. Radical 4 times x plus 1 is 25. So we get radical 25 minus 5. 5 minus 5 equals 0. So yes, we get a valid answer. It's not an extraneous solution. We get x equals 6. Okay? So that is, again, square root equations. Now we're going to take a look at solving rational exponent equations. And again, if you remember, rational exponents, another word for fractional exponents. So first, let's just read this instruction. So to solve equations of the form x to the m over n, right, which is a fractional exponent, equals k, we raise each side of the equation to the power n over m. If you notice, these two are reciprocals. So this is telling us we're going to raise our rational exponent to the reciprocal power. And that is our way of undoing a rational exponent. So if we raise to the reciprocal, we undo the exponent, okay? And now again, if m or n is even, okay, which is going to make our denominator even, then we have to worry about absolute value. And again, that is our way of making sure that we find the principal root, right? So we're going to talk about, that's going to come up in one of our examples here in a second. So we'll talk about that when we get there. But first, let's look at a real simple equation. So we have x to the 2/3, and we want to, so we have x to the 2/3 equals 16. So we want to find some value of x that when raised to the 2/3 is going to give us 16. So again, if we look back up here at our steps, we want to isolate the rational exponent equation, which in this case it already is by itself, and we want to undo it, undo the rational exponent. So to undo that, we're going to raise it to the reciprocal, which the reciprocal of 2/3 is 3/2. So we want to raise both sides to the reciprocal of 3/2. And again, let's take a look at why we do that. If we multiply 2/3 by its reciprocal of 3/2, we get 6/6, which is 1. So again, that gives us an exponent of 1, which basically gets rid of our exponent, right? Just like squaring a square root, got rid of the exponent, got rid of the square root, multiplying by the reciprocal gets rid of this exponent. So now on this side of the equation, we get x to the 1st equals 16 to the 3/2. Again, if we look at 16 to the 3/2, based on our last lesson, we know that we can think about that as the square root of 16, which is 4, cubed, which is 64. So we get x equals 64. And again, if you can't do that in your head like I just did, you can use your calculator and say 16 to the 3/2. Sorry about that. 16 to the 3/2 equals 64. Okay. So again, that's just a simple example of how raising to a reciprocal power simplifies your exponent. Okay, so these get a little bit trickier. Let's look at a couple more examples. So here's another little summary of what we're going to do. So we know the equation and the power. We need the solution. So we're going to isolate the exponential expression and use the inverse of the power to simplify and solve the equation. So, and again, by inverse, we're talking about a reciprocal. Okay, so let's take a look at this one. So here we have our equation. Again, in order to isolate the rational expression, we want to get that by itself. Currently it's being multiplied by 3. So to isolate that, we want to divide by 3. So then we get x plus 1 to the 2/3 equals 4. So we've isolated the rational expression. And now we want to undo the rational expression. So undo the rational exponent. So to undo that, we're going to multiply by the reciprocal. Again, we have to do that to both sides, right? Because we have an equation. So when we multiply by the reciprocal, we're going to get an exponent of 1. So we get x plus 1 to the 6/6, right? Which equals 1, equals 4 to the 3/2. Again, if you think of 4 to the 3/2, it's going to be 8, right? Because you can think of the square root of 4 is 2. 2 cubed is 8. So 4 to the 3/2. Again, if you think about it, is 2 cubed equals 8. Okay? So now this is where the absolute value, though, comes in. This gets a little bit tricky. Again, because our denominator here is even, which we can think about, if we looked at our rule here, if m or n is even, okay, which if either of those is even, then our denominator is going to be even. Then we need to think about the absolute value. And this is our way to make sure we find the principal root, right? That our answer will work for, will end up being a positive value, okay? Because we're looking for a positive root, we have to have a positive value. So at this point, if this is even, okay, which it is, then when we go to solve it, we have to think about, we have to find the absolute value of x plus 1 equals 8, okay? And again, this is all focused on making sure that our answer, that what we're taking to that power is even. So this only comes into play when your denominator is even, okay, because that's when our principal roots come in. Because again, if we're looking for an odd root, negative values are okay. Let me kind of note that here. So we need the principal root, which must be positive, and that is when our denominator is even, okay? So instead of just saying x plus 1 has to equal 8, we have to look at the absolute value of x plus 1 equals 8. And if you recall, when you have an absolute value expression equal to 8, that means that x plus 1 can equal 8, or x plus 1 can equal negative 8, right? If you look back at what we learned about absolute values, that absolute value of x plus 8 means that what's inside those bars could equal 8 or could equal negative 8. So when we solve those, we get x equals 7 and x equals negative 9. Okay? Now again, it's okay that x can be negative 9, possibly. Just getting a negative value for x doesn't mean we're wrong. It just, because the expression that we're using with that x has to end up being even, not necessarily just the value of x, okay? So we can plug it in. So again, this is perfectly fine. You just need to check absolute value bars when you're expressing the answer for an even root, okay? But now we have two possible answers, and we need to check them. So to check them, we plug them into our original equation. So again, we go back to the original. Which was 3 times x plus 1. So I'll do the 7 first. 7 plus 1 to the 2/3 equals 12. So if I check that, I get 3 times 8 to the 2/3 equals 12. And again, cube root of 8 is 2. Square it is 4. So I get 3 times 4 equals 12. 12 equals 12. That answer is good. Let's try another one, or let's try the second answer. So we get 3 times negative 9 plus 1 to the 2/3 equals 12. 3 times negative 9 plus 1 is negative 8 to the 2/3 equals 12. Now, again, we have a negative x value, but that's okay. We're looking at taking the negative 8 to the 2/3. Again, this is negative, but so is our root here. So the cube root of negative 2 is, the cube root of negative 8 is negative 2. We square that, we get positive 4. 3 times 4 is 12. That's all good. So again, even though we had an even root here, and we had to use absolute value bars, that led us to a negative x value, but it is a valid answer. So, so it all checks out. We're good. Okay? Again, the absolute value bars are only necessary when you have created, when you're looking for an even root, so when your denominator is even. So let's check another one. So let's take a look at this. Again, what is the solution of 3 times the 5th root of x plus 1 cubed equals, plus 1 equals 25? So again, first step is isolate the radical. So first let's subtract 1. So we get equals 24. Now, again, you never want to distribute into any kind of a radical or a rational expression. So this 3 on the outside means divide to get rid of it. It means multiplication. So now we get the 5th root of x plus 1 cubed equals 8. Now, again, we don't like this whole radical setup, right? The way it's written, right? So let's rewrite that using rational exponents. So that becomes x plus 1 to the 3/5, if everybody agrees with this. Again, that's our index. That belongs on the bottom of our rational exponent. So we get x plus 1 to the 3/5 equals 8. Okay. Now, to undo the 3/5, we're going to raise the whole thing to the 5/3. So 3/5 times 5/3 gives us 1. So we get x plus 1 to the 1st. And again, we have an odd denominator. Okay, that ended up to be, let me write that a little more clearly here, 15 over 15. So it is odd, so we do not have to worry with our absolute value, okay? Because we're only going to get one answer. So it's odd. So so we do not have to check absolute value. Sorry about that. No absolute value needed. Okay. So we get x plus 1 to the 1st equals 8 to the 5/3. And again, if you put that in your calculator, it's 8. The cube root of 8 is 2 to the 5th power, is 32. So we get x plus 1 equals 32. We solve, we get x equals 31. So again, we just got one answer, which is fine. But again, we still want to check it because we could still get extraneous solutions, okay? Anytime that you're taking two sides of an equation with a variable to a certain power, you can get extraneous solutions. So we do want to check it back in our original equation. So we get 3 times 5th root of 31 plus 1 . Let's see, let's look back up here. 31 plus 1 cubed plus 1 equals 25. So if we simplify this, we get 3 times 5th root. 31 plus 1 is 32. Plus 1 equals 25. So let's plug this into our calculator. Let's look for, let's see what 5th root, let's kind of do this the old-fashioned way. Let's go down to 5. Let's do the 5th root of 32 to the 3rd. Okay, so again, this is another way. We could have done 32 to the 3/5, but another way to plug this in, the 5th root of 32 to the 3rd is 8. So this becomes 3 times 8 plus 1 equals 25. Gives us 24 plus 1 equals 25. So we're good. So that checks out. Okay, so again, important here to learn the steps and follow the steps, right? So we isolated our rational, or in this case it was a radical, but we isolated it, right? We got it down to all by itself. So right here we isolated it. Then we took it to the reciprocal power to undo it, right? So we isolated it, then we went to undo it. Then we got down to a simple equation and solved. And then we came over here to check. Right? So it's important, again, to memorize the steps. So let's do another one. So again, we've got this equation. First thing we want to do is isolate the rational expression. So we have to get those parentheses by themselves. So we divide by 2, and we get x plus 3 to the 2/3 equals 8. We need to undo that radical. So we're going to take it to the 3/2. And again, we have to do it to both sides, because anytime you're working with an equation, again, what you do to one side, you do to the other. And honestly, I just saw a mistake here. 8 divided by 2 is 4. Okay, so now on this side of the equation, you get x plus 3 to the 6/6 with 1 equals 4 to the 3/2 is 8. Now again, this is even. So we have to make sure we get the principal root. So we're going to need the absolute value bars. So this becomes absolute value of x plus 3 equals 8. So we get x plus 3 equals 8, or x plus 3 equals -8. And again, if this is confusing you, you may want to look back into chapter 1 where we looked at absolute values. So, you know, why this is happening, right? So this is becoming two equations because of the absolute value bars. So our two answers become x equals 5 and x equals -11. Okay, and again, we're okay with getting a negative x value. That does not tell us anything we have to worry about at this point if it works out in the equation. So those are our two answers. We want to check them. So if we check 5, let's plug that in the original equation. So 2 times 5 plus 3 to the 2/3, does it equal 8? 5 plus 3 is 8. So 8 to the 2/3, again, cube root of 8 is 3. Cube root of 8 is 2, squared is 4, so we get 2 times 4 equals 8. So yeah, that checks out. We check the next one, we get 2 to the -11 plus 3 to the 2/3. Does that equal 8? -11 plus 3 is -8. And again, we could take a cube root of a negative number. So this is also going to give us a +4. And we get 2 times 4 is 8. So yeah, they both check out. So no extraneous solutions. So our two answers are 5 and -11. Again, if this is confusing to you, or if I'm going too fast, pause it, rewind it, you know, review it. So that's the benefit of digital learning days, is I'm on video right here, or on recording. Okay. Okay, so next we're going to go through just a couple little word problems. Okay, so let's take a look at an word problem that uses a radical equation. Okay, so in this example, so we have a meteor crater in Arizona with this formula that relates the diameter to the volume of the crater. So what is the volume if we're given the diameter? So we get the diameter is 1.2 kilometers, which is actually, we're going to take this down to meters. So that is 1,200 meters. So again, if we know, the diameter is 1,200, so we can plug that in. So we get 1,200 equals 2 times the cube root of the volume divided by 0.3. Okay? So again, we can solve this. We're solving for v. So again, we're dealing with a cube root here. So we need to get the radical all by itself, which in this case is a cube root. So to get that by itself, we divide both sides by 2. And we get 600 equals the cube root of volume divided by 0.3. And again, that 0.3 is part of the radical. So we can't do anything with that, again, until we get rid of the radical. So to undo a cube root, again, this would be the same thing. This would be equivalent to saying v divided by 0.3 to the 1/3, right? Because 1/3 and cube roots, same thing. So either way, we would take it to the 3rd power. That would undo, either way we're looking at it, right? That would take away either the rational exponents or the cube root, and we would get 216 million, looks like. 216, again, 600 cubed is 216 million equals volume divided by 0.3. So to solve for v, we would multiply both sides by 0.3, right? Again, even though the numbers are big and decimals, same rules of algebra apply, and we would get volume equals 64,800,000. And that would be meters cubed because it's volume. Okay, so again, just another example of solving for that volume, for that using a cube root. Okay. Okay. Now we've checked for extraneous solutions, but we really haven't seen any yet, right? And similar, and I want to go over really some examples where it's more prevalent and chances are bigger that you're going to get extraneous solutions, and that is when we have a variable on the other side of the equal sign. Okay, and that's just, if you recall, this really takes us back to our absolute value equations back in chapter 1. Back in September. So it really might be helpful for you guys to go back and look through that section. That was 1.6, I think, if you want to look through the absolute value. But anyway, let's take a look at this. So chances of extraneous solutions really come into play, again, like as I said, when you've got a variable outside the radical as well as inside the radical. So let's go through and solve this the way we've talked about. So again, first we're going to get the radical by itself. So we add 5 to both sides, and we get radical x plus 7 equals x plus 5. Okay. Same rules apply. To undo the radical, we need to square both sides. Hopefully some of you are starting to kind of giggle or trying like, uh-oh, let's see where this is going. Okay, so radical x plus 7 times radical x plus 7 is going to give us just regular old x plus 7 on this side. But over here, x plus 5 squared means we have to FOIL, right? And don't forget FOILing here. So on the right side of the equation, we get x squared plus 10x plus 25. Now we need to solve. So again, you can already tell we're going to need to factor, probably, right? So if we're going to need to factor, we're going to have to set everything equal to 0. So we're going to subtract x and subtract 7. See, I told you guys you'll need factoring all throughout your life. And here it comes up again. So when we solve that, we get x squared equals 9x, x squared plus 9x plus 18. And again, we need to find what would make that equal to 0. So we think what multiplies to 18 adds to 9, and we get 6 and 3, or x plus 6 equals x plus 3. And we solve those, right, to find out what values that gives us, and that gives us x equals negative 6 and x equals negative 3. Again, be careful. When you come up with the factors about what multiplies to 18, adds to 9, again, that's positive 6, positive 3, but then you have to set equal to 0 to actually find out the solutions, right? So we are saying that our solution is x equals negative 6, negative 3. Now we need to check those. And again, the main thing that we talked about when you're checking for extraneous solutions is setting them into the original equation. So if we plug these into the original equation, over here we plugged in -3. So the -3 goes under the radical and on the outside of the equation. So when we set that up, we get radical 4 minus 5 equals -3. 2 minus 5 equals -3. -3 equals -3. We're good. Okay. Let's see what happens when we do -6. So we plug in -6 to both values of x, inside and out. -6 plus 7 gives us a +1. -5 equals -6. Square root of 1 is 1. -5 does not give us a -6. It gives us a -4. So that is not a solution. So again, you want to plug into the original equation. So now we can mark this one out, which is just how I would want you to do it. You can just put an X through it, and that tells me that you checked it, and it is not a solution. Okay. All right, let's do one more of those. Again, isolate the radical. So we get radical 5x minus 1 equals x minus 3. Get rid of the radical by squaring. So we get 5x minus 1. So they got rid of the radical on the right side, or the left side, I'm sorry, but then it's going to make us FOIL on the right side, right? So we get 5x minus 1 equals x squared minus 6x plus 9. Again, we can tell we're going to have to factor, so we're going to get everything on one side. So again, everything you've learned thus far is kind of coming into play here, right? So we get 0 on the left side, we get x squared minus 11x plus 10 on the right. And again, we factor what multiplies to 10 adds to -11. It's going to give us minus 10 and minus 1. Set those equal to 0. We get 10 and 1. Now we need to check it. So I'm going to check it over here. So I'm going to say radical 5 times 10 minus 1. You be careful what's inside the radical and what's outside when you're checking these. So we get 50 minus 1 is 49, plus 3 equals 10, 7 plus 3 equals 10, so 10 is good. Okay. Let's check out 1. So if we check radical 5 times 1 minus 1 plus 3 equals 1. So 5 minus 1 is 4. So radical 4 is 2 plus 3 equals 1. And no, it doesn't. So it does not equal 1. So 1 is not an answer. So 1 is an extraneous solution. Okay? All right. So, ladies, as I said, we've this kind of been a big lesson, kind of went a little longer than I thought, but you've got the videos, you can take a break, slow it down, rewind, whatever you need. I have posted the 6-5 practice problems, so take a look at those, work on those. Answers will be posted. B-block, I'm going to go ahead and post them for you guys to help with the review, I think. And anyway, B-block, we'll talk about it next time, or I'll probably go ahead and post all the answers in a little while. Again, we're kind of making this up as we go along with some of this, but anyway, I will post those answers, so check them out. Email me if you have any questions. Otherwise, we'll talk about it with reviewing in our review sessions. But again, I would, if you have questions about this specific lesson, I'd like to hear about them before we do our review, just to help the review go smoother. So anyway, stay safe, ladies. Stay well. I miss you guys. I hope to see you all after spring break to finish out the year. But anyway, hope all is well. And email me with questions. Thanks, girls. Bye.